Hi group, it's Mrs. Schaus here to talk about average rate of change. That's Learning Target 2.7, but it is from section 2.4 in our new pre-calc textbook. When we think about finding the average rate of change, we want to be able to do that in two ways. First of all, by using a graph, and secondly, in an algebraic way. We're actually going to begin with the algebraic approach. Now, average rate of change is something that you have been studying not only in Algebra 1, but again in Algebra 2, and probably for a variety of different types of functions. Sometimes when we're in Algebra 1, we think of slope as the average rate of change. Slope is a type of average rate of change. It's just that not all rates of change are associated with a line. All right, a formal definition says, for the function y equals f of x, between x equals a and x equals b, the average rate of change is f of b minus f of a over b minus a. Again, this formula is very similar to what you've seen in calculating slope. It's just change in y over change in x, right? All right, and that's what I said down here. Just a change in y over change in x. I want us to consider a function that is not linear, f of x equals 4 minus x squared, and find the average rate of change of the function between the given values for this particular variable x here that's given. So here our x is -2 and our x is -1. And in order to calculate the average rate of change, we need to know what the outputs or the y values are. So if I plug in -2 here and square, that gives me 4. 4 minus 4 would give me 0 for an output. For the next one, f of -1, when I plug in -1 here and square, I get +1. 4 minus 1 would give me an output of 3. So now to apply the formula, the change in my outputs over the change in my inputs, I would get, move this down a little bit, 3 minus 0 over -1 minus -2. But of course we know minus a -2 is really addition there. I'm going to move over to the right here. So on top I've got 3. Down below I've got -1 plus 2, which would give me 1. So the average rate of change between x equals -2 and x equals -1 is 3. Let's move over here where we're looking at some different values of our x variable. Let's find the output when x is 0. 0 squared, of course, is just 0, so I get 4 minus 0, or 4 is my output. F of 1, putting in 1 squared here gives me 1. 4 minus 1, I get an output of 3. And once again, when I apply this formula, I get, turn those lights back on, sorry, I get 3 minus 4 over 1 minus 0. Across the top here, I've got a -1. Down below, 1. -1 over 1 is just -1 overall. So why the different average rates of change for this particular function? Again, because it's not linear. If it were linear and average rate of change is really the same thing as slope, then it wouldn't matter what 2 points that we'd select. We'd always get the same average rate of change or slope. But again, we don't call it slope here because it is changing. I want you to think for just a minute about what we've been studying with parent functions. Y equals x squared is this parabola that opens upward, but since there's a negative leading coefficient here, it would open downward. And I know we haven't studied all transformations yet, but essentially that +4, +4 there, would shift it up 4 units. So it would look something like this. And I know I didn't put any markings on this graph, so it's just a sketch kind of thing. But I want you to think that if your x values were on the negative side here, somewhere, over in here, right, that the function is increasing. So to have a positive average rate of change would make sense. And similarly, if I go from 0 to an x value of 1, for whatever piece that might be, this would be dropping back down. And so again, our average rate of change being negative would make sense in the problem. Okay? All right, let's take a look at a couple of other functions, and again, just some more algebraic calculation and finding average rate of change. I'm just going to find the outputs for these x values. So when I plug in 0 here and here, I just get 0 as a result. For f of 4, I have to do 4 squared, or 16, minus 4 times 3, which is 12. 16 minus 12 gives me an output of 4. And once again, the average rate of change equals the change in y's, so 4 minus 0, over the change in the x's, 4 minus 0. I get 4 over 4, or 1. All right, let's take a look at another. Now, what's different about this one? They're giving us x equals 0 and x equals h. So it's not an actual numeric value. That's okay. We know the process for calculating the rate of change. We start out by finding the associated y values. If I plug in 0 for x here, I get 3/2 as my output. And for f of h, I would get 3 over h plus 2. Once again, for this average rate of change, that's going to equal the change in these y values, the outputs, so 3 over h plus 2 minus 3/2 over, and then the change in the x values, that's h minus 0. So the denominator here is just h. Wow, I've got to go back to that whole idea of trying to combine rational expressions. In order to do that, I must have a common denominator. So I need a factor of 2 and a factor of h plus 2. That means for this first fraction, maybe I'll come down below and work there. Okay, so for this first fraction, I need to multiply by 2 on the top as well as on the bottom. And for the second fraction, I need to multiply by h plus 2 on the top as well as on the bottom. All right, and that's all over h. And so now I'm going to do this subtraction and keep the common denominator. Sorry about the bell. There we go. So I've got 6 minus, I can actually distribute this -3 through here at the same time, but I'm trying to write the subtraction. So that would be -3h, and then minus 6 all over our, I think I'll write the 2 out in front rather than at the back. So 2 times h plus 2. And that is all over h, but remember I told you folks that's the same thing as multiplying by the reciprocal, so 1 over h. When I try to clean this up, the +6 and -6 will cancel with one another, and that leaves me with -3h over this quantity, over 2 times the quantity h plus 2, and then times 1 over h. But I can also say that this factor of h, because it's multiplication, right? This factor of h cancels with the h that I see up top here. And so the entire average rate of change can be written as the expression -3 over 2 times the quantity h plus 2. And certainly you could have distributed that too if you preferred, but that is our expression for average rate of change there. All right, let's just talk a little bit about finding average rate of change graphically. And because it is a graph, I'm going to try to move down a little bit closer here for you to see. Okay, so in a graphical sense, we're still trying to square it up a little. We're still trying to do the same thing where we want to say if I'm finding average rate of change between some x values, I have to know the y's associated with those. I'm not finding them through an equation, but through a graph rather, and I'm still going to calculate the change in y's over the change in x. So let's start out here with an x value of -2. If I read up to the graph, oh, it looks like it's right, I think it's supposed to be right here. I'm going to call it right on that line for, again, lack of having a better graph to consider. So at -2, it looks like we're up 1, 2, 3, 4, 5, 6. I'm going to call f of -2, 6. And then how about f of -1? Well, when I look at where the x is -1, I'm actually crossing the x-axis, so that means the y value would be 0. So if I've got my outputs here, inputs were there, I can calculate my change in y over change in x. I don't know if you guys have seen this symbolism before. The delta, the Greek letter delta means change. So this is a shorthand way for me to say change in y's over change in x. So that would be 0 minus 6 on the top, and down below here for the x's, negative 1 minus negative 2. So what do I get up top? Negative 6. Down below, if I really make this a plus 2, negative 1 plus 2 is a positive 1. So just to clean that up, the average rate of change is negative 6. Okay, let's take a look. I'm writing uphill because my paper's at an odd angle. Sorry. All right, for this one, again, I've got to know what are my outputs here. F of 0. Well, when the x value is 0, that means I need to read down to find the y value, which is at negative 4. And when x is 1, again, I'm crossing that x-axis, so the y value is 0. And I'm going to calculate change in y over change in x. That is 0 minus negative 4 over 1 minus 0. Up top, I just get 4. Down below, I get 1. And again, 4 is my cleaned up version of the average rate of change. Now, what I should, again, notice graphically about this function is that between negative 2 and negative 1, the graph is heading down. So my average rate of change should be negative, and it is. And between 0 and positive 1, the graph is heading up. So my average rate of change should be positive, and once again, it is. So hopefully this helps you folks to find average rate of change both in a graphical sense and in the algebraic sense that we had considered together at the start of the video. You'll practice some exercises on these skills, and again, we'll talk about questions that you still have in class. Make it a great day, folks, and I'll talk to you soon. Bye-bye.